All right, programming 12. So we just finished taking a look at how the darkness is laid out in a grid type pattern. And that same algorithm we can use to do a bunch of stuff with grids, including drawing the mini-map. So that's one of the themes of this project for sure. So in this video, we'll take a look at how you can adapt that grid processing algorithm for the mini-map. And I think that'll be a good hint towards making it work. Okay, so I won't remind you exactly how that algorithm works because you can watch the last video if you want to go into details to see what's going on with that. Okay, so let's take a look at the actual mini-map itself and see what's going on. That's not Command K. Oh, where did it go? Yeah. Okay, sure. This will work. So here's our image, map.png. Oh, I can't really see it, hey? Let's make it bigger. Oh, there it is. It's all fuzzy. And actually, I just made it sharper by pinch zooming. But that's that fuzzy image that you saw earlier. I don't know if I can get it back. Yeah, this is the reason we can't just draw the mini map as a picture. It is going to be, all fuzzed out as we enlarge it. The algorithm for enlarging, the default algorithm for enlarging the picture is going to make this all fuzzy. So, it turns out this is the way we want to draw it. And the Mac operating system apparently can handle that, but, we're going to have to do it manually in processing. So what we're going to do is we're going to write a loop that looks a lot like the loop that was, laying out our darkness in a grid. And what we'll do is we will write that loop to go through our map one row at a time, taking a look at these pixels. So it'll look at the corner pixel first, and then the next pixel, and the next pixel, and so on. And each time it'll look at the pixel, and it will draw a larger picture, a larger square to represent that pixel as part of our mini-map. Our mini-map, let's see. Our mini-map is actually a bunch of squares. Can I zoom in? Yeah, there we go. This mini-map is actually made of a whole bunch of small squares. And each square I'm just drawing from the mini-map in that loop that's processing, I don't know where it went, but processing this image here. So I'll look at this pixel, and then I will draw a corresponding square on my screen. And then I'll go to the next pixel, across the row, and draw another square beside it on the screen. And I'll do that until I get to the end of the row, and then I'll have an if statement that will bring me back to the beginning and go down again. And then I will take a look at each one of these pixels and draw corresponding squares to the screen. So that's sort of my plan for the mini-map. I hope that makes sense. So how does this algorithm do that? I mean, and I guess also where does that code go? So, it'll be kind of similar, but we just won't be doing this darkness stuff. No. That's totally something else. We want to read from the map, and we want to draw squares on the screen in the same sort of pattern. So where, first of all, is that code going to be? Probably in your game, in your game function somewhere. This is, of course, the function that handles the draw function during mode game when you're playing your game. So, I've got mine broken into functions. I draw the room. I draw the objects that are in the, world. I draw the light layer, and I draw a mini-map. So the mini-map is the last thing because I have it on top of the darkness so that I can see it. So in Draw Mini-Map, I will have a similar loop to this. And I will also start x at 0 and y at 0 because those coordinates will represent the pixel that I am looking at in my map.png. And I'll probably have similar sort of things, except that I can't use height. Height is the screen's height. I want to go until I get to the height of the map. But fortunately, you can say that. You can say map.height. That will be the height of the picture. You can also say map.width for when you want to do this. Now, by the way, I don't want to actually edit my darkness code, so please don't make this change here. This code is not meant to change. I'm just showing you, based on this algorithm, when you go to write this code over in your draw mini map function, these are some of the changes that you can expect to make. All right, so now instead of drawing darkness, what am I going to do? Well, I'll read the color. Well, how do you read the color? Well, we've done that before, actually. When we draw the exits, we use the map function here, right? Map.get. So we could make a color variable that stores whatever color is at that location. So then, assuming this code was in my game function, I'm not actually editing my darkness code, I would do a similar thing. I would say map.get xy. And I would store that in some temporary color variable. Color, C or something, equals map.get. And it's a lowercase c. And then, what would I do? Well, then I would draw a square. Well, I guess I'd fill with my color first, and then I would draw a square. Square. And I wouldn't draw it X and Y. I would probably make it size, but X and Y is not the right place to draw it. And you might wonder why. Well, the answer is because X and Y is really more about the pixelated image, which is made up of a bunch of 1 by 1 pixels. So I can't depend on drawing it X and Y. Those are going to be sort of, 1 pixel over. When I go to change my pixel, I'm going to say X equals X plus 1. I go over to the next pixel. But I want to draw like a 4 by 4, or a 5 by 5, or a 10 by 10 square. So if I'm going only over by 1, that's not gonna do the trick. So I'm going to have to somehow magnify this. So, basically, when I go to get to the map.width, I'm going to set x by 0, and then I will change y by 1. Y equals y plus 1. So what is it that I have to do here? So these coordinates aren't sufficient, but you can, do additional stuff with them. You can multiply them by a value so that you can, instead of going up by 1, 2, 3, if I multiply them by, say, 5, I'm going up by 5, 10, 15, 20. And then you can also add to them to shift them around in the screen. So if you, look at where I'm at, I'm not starting at 0, 0. I'm starting here, which is like, 50, 50. So you can also add to these dimensions here. So multiplying and adding, possibly, think about what number it is you need to multiply by to make that work. So this is sort of the layout of the mini-map function. Of course, this has nothing to do with darkness, so please don't make the mistake of changing the darkness code. That is clearly not what we're trying to do, so I'm going to go put that back. This is just sort of, you're going to use a similar while loop, and that's the kind of changes you'll make. I'll leave it up to you to sort of figure out the last details of it, and you can place it wherever you like on the screen. I think that'll be great. Last but not least, you might be like, oh, well, how do I draw the little dot that indicates, hey, I have a purple dot. I'm not sure. I broke my stuff here. Doesn't matter. I'll keep going. So, what about that purple dot that says, oh, you're here, now you're here, now you're here? That's actually an additional dot that I draw on top of the mini-map after I have drawn the mini-map. So the last thing I do in that mini-map function is to look at the hero's room X and room Y variable. And then I apply the same math to that, because that's going to be sort of a pixel number. So whatever kind of multiplying and adding I did to each individual square of the mini-map, I'll do that to room X and room Y as well, to stick it some kind of color or something to indicate where I am on the mini-map. So all this code is going to be going on in game, and of course I made myself a separate function to keep it organized. So that's what you can expect to try to make as well. Okay, so good luck with that, and I hope things are successful for you. Okay, bye.